These will be our last notes for the semester. After today, you will know how to do every single question of the UH Test 1 derivatives. Cool? After today, we have 2 other UH quizzes. One of them is pretty simple, and one of them is kind of like medium. But you know everything there is to know other than MVT, which we're covering today. So we're covering MVT and antiderivs. I think we're pretty good with mostly everything. The mean value theorem is not a hard theorem. So yeah, let's see. Today notes, Tuesday circuit, Wednesday review, Thursday circuit, Friday your time, like your UH quizzes, finalize them, whatever. And then next week is semester exams, and that's it.
Are you taking it second period?
We're taking it second period. You don't have an exam ninth period. So ninth. So what? That's it. Once you take it seventh period, we are done. And you guys are first priority, so I will grade your exams first. Any questions before? Any questions on the breakdown or anything else? We're good? All right, here's the last idea, the mean value theorem. So you have a formula, and it said, let's see what the mean value theorem says. It says theorem 3 because I got this from a textbook, that little box here, because they give you, so it says from the Demana textbook, if you're wondering. That's the textbook that you guys are supposedly have in the school district, but we haven't been using them. If y equals f of x is continuous at every point on the closed interval a to b and differentiable at every point on its interior a to b, there is at least one point c on a to b at which the instantaneous rate of change equals the average rate of change. So that's what this means. This is your average rate of change. This is your instantaneous rate of change. All right, so what does the equation even mean? So look, I have it right here. It basically just means that the instantaneous rate of change equals your average rate of change, given your conditions for you to use the MVT exists. Continuous on the closed, differential on the open. So that means, Chavez, what does that mean? Can you show it? Okay, I'll show you in a little bit. What does that mean in terms of pictures? Okay, so the average rate of change from A to B is whatever this slope is. Whatever that slope is the average rate of change. Does that make sense? And then the instantaneous rate of change, you can see that right here, this tangent line is parallel to the secant line. That's all it means. That's all it means. So let me give you an example of this, where it's continuous on a closed interval, but differential on the open. So if I have something like this, like a semicircle, here's A, and here is B. Do you see that semicircle I have there? I know you don't have a derivative at A because it looks like a vertical tangent. You don't have a derivative at B because it looks like a vertical tangent. But I don't have to have a derivative at A and B as long as I'm differentiable on the open interval. Does that make sense? So the average rate of change from A to B is 0 because, look, it's just a horizontal line. Well, where's my C? The C is right here, right smack in the middle. I have a tangent line that is parallel to that secant line. Cool or not cool? Cool. And then what did I write? Hopefully you can see the graphical interpretation of MVT. Yeah, sometimes don't say, it is a bad habit. I should have written better notes. Don't say MVT, say mean value theorem. Yeah, next time I'll change my notes because sometimes I'll write MTV or something, Do you guys know what MTV is? Music, television? Okay, I don't know. Yeah, don't write MVT, write music, mean value theorem. Yeah, I was about to say that, but means that if you can connect the endpoints of the graph interval with a chord or form a secant line, there will be at least one point on the graph where the tangent line is parallel to the chord. Chord means that, right? Meaning that the instantaneous rate of change is equal to the average rate of change. Cool, right? Remember, conditions must apply. Okay, whatever. Okay, Chavez, can you give me an example in English, not using picture or math symbol? Excuse me. Yeah, I can. So let's say you have some friends at Cass Tech, and you take your car to Cass Tech, and you drive there, and your odometer says that your average speed was 43 miles per hour. Did you at any time travel exactly 43 miles per hour? Yes. No, definitely 100%. How many times did it happen? I don't know. Maybe several times. But if your average speed was 43 miles per hour, your instantaneous rate of change had to have been 43 miles per hour somewhere, at least one time. Maybe you put it on cruise control and it was 43 the whole time. Does that make sense, guys? So that's all it means. That's the average equals your instantaneous somewhere, as long as you're differentiable on the open interval and continuous. Now, if you are not differentiable, look at this. See how on this one, and I'm going to call this F because I did a bad job of labeling this. See how on this one, there's a point that's a corner and you're not differentiable? Then the mean value theorem does not apply. You have to be differentiable on the inside. Chav, why does it not apply? Well, look, this tangent line looks like that. This tangent line right here looks like that. There is no tangent line that is parallel to my secant line right there, A to B. Do you see that, guys? So you must be differentiable. It must be continuous on the closed, and you must be differentiable on the open. Yay or nay? Okay. All right. So let's work. It's okay. It's very easy to be a robot for this. Try really hard not to be a robot. It's very easy to be a robot. So all we're doing is your derivative. Let's read this. It says, show that the function f of x equals x squared satisfies the hypothesis for the mean value theorem on the interval 0 to 2. Then find a solution C to the equation f prime of c equals f of b minus f of a over b minus a. Okay, x squared. How does that look? It looks like this. From 0 to 2. And I have a point. That point here is 0, 0. And I have a point. That point is 2, 4. We still okay? The slope, and let me see, what burnt orange? UT. The slope of that line right there, that's my secant line, is nothing more than f of 4 minus f of 4. F of 2 minus f of 0 over 2 minus 0. All I'm doing is the right side of this MVT. Have that confused anyone? Okay. F of 2 is 4. So 4 minus 0 divided by 2. Are we still okay? Equals 2. So the slope of that dashed line that you see is 2. Yay or nay? I want to find a tangent that has that same slope. It looks like right there. See how that purple line looks like it's parallel to that secant line or to that burnt orange dash line? I want to find what coordinate that is. So here we go. All I'm going to do, I'm doing the left side now. I'm doing the left side. F prime of x equals 2x. Are we still all right? I'm going to take that 2x. I'm going to go f prime of c, because that c just means some x value. You don't have to put c, guys. 2c equals 2. And look where it happens. So 2c equals 2, so that means c equals 1. That's just an x value, so don't freak out. At x equals 1, I have a tangent slope that is parallel to my secant. I have a tangent line that is parallel to my secant line. And there it is. So what's the c value that makes this happen? 1. And that's it. That's all MVT is. Are we okay? Hit me. What's the question that we have? Hit me. Hit me, Espinosa. What question we got? Yeah, my tangent is parallel. Oh, yeah. Yeah, you just instantaneous rate of change equals average rate of change. Where does that happen? At x equals 1, my instantaneous rate of change is the same as the average rate of change from 0 to 2 of this curve. Cool or not cool? Cool. All right, look at this. This is coming from UH. I stole it and I put it in there this morning. Yes, so I'm giving credit to UH. Here it is. I literally, this is one of the questions that we always get wrong in years past. Every group is different, so I shouldn't judge you guys because you haven't even taken the quiz. But I have access to like the last 4 or 5 years, and this question I see that a whole bunch of kids always get it wrong. So let's see what this is. The function f is graphed below on the interval 0 to 10. Okay. Give the number of values c. So c is how many times it happens between 0 and 10. Give the number of values, underline number of values c, between 0 and 10, which satisfies the conclusion of the mean value theorems. So how many times does it happen? That's what c is in this one. How many times does MVT, how many times does MVT, how should I say it, satisfy? MVT satisfied. I'll just put it for now because it's between 0 and when it satisfies the conclusion of the mean value theorem for F. So all it means is how many tangent lines do I have parallel to my secant line? So Chav, what are you talking about? What secant line? I don't know what you're talking about. Here's x equals 0. Here's x equals 10. Make a straight line. I want to know how many times is my instantaneous rate of change equal to my average rate of change. That purple line is my average rate of change. Well, the purple line itself is not that. The slope is the average rate of change. Are we okay? Okay, so let me make sure everyone understands. The slope of this purple line is the average rate of change for between point A and between point 0 and point 10. Until x equals 0, x equals 10. Cool or not cool? How many times do I have a tangent line that has the same slope? Let's see. For sure, somewhere right here. You guys see that? That's one. And then it looks like right there. 2, right before I hit that. And good job, Espinosa. Another one right there. 3 times. Do you guys see that? So, 3 is the answer. Cool or not cool? Yeah, nothing crazy, nothing crazy. All right, don't freak out. If you see something called Rolle's theorem, it's just a special case of MVT. That's all it is. So underline the word Rolle's theorem. It means it's a special case of mean value theorem. And I put the expression in here, but it always helps to write it out. What is that special case? It's this. F prime of C equals F of B minus F of A over B minus A. Look, that's MVT right there, which equals 0. Rolle's theorem just means it equals 0. That the average rate of change is 0. Where's my instantaneous rate of change? 0. And it says right here, if f is continuous on a closed interval a to b, differentiable on the open interval a to b, then f of a equals f of b, then there exists at least one number c on the interval a to b in which f prime of c equals 0. It makes sense. If the y values are the same at a and b, that means I have a horizontal secant. It doesn't have to, man, next time I'm going to choose a different one. It doesn't have to equal 0. On this one it equals 0, and I don't like that. So look, let's do the average rate of change first. Let's just do this. F of B minus F of A over B minus A. Let's see what the question says. Determine if Rolle's theorem applies. So the average rate of change has to equal 0 on this function. I already know that function is continuous and differentiable. It's just a polynomial. On 0 to 3, if so, find all numbers C, so they want the actual x value, on the interval that satisfy the theorem. Okay, here we go. F of 0. F of 0 is 0 cubed minus 9 times 0 equals 0. Dang. I wish I would have chosen one that doesn't equal that. That's fine. F of 3. 3 cubed minus 9 times 3, which equals 3 to the third power. 3 times 3 is 9. 9 times 3 is 27. So 27 minus 27, which equals 0. Does f of 0 equal f of 3? Yes. It does not have to equal 0. Well, okay. The average rate of change has to equal 0 for Rolle's theorem. But f of 0 and f of 3 do not have to equal 0, guys. It could have been like equals 5. And as long as f of 0 equals 5 and f of 3 equals 5, then Rolle's theorem applies because the average rate of change is 0. Does that make sense? Okay. It applies. My average rate of change is 0. So that means now I'm going to find the x value where this happens. I'm going to take a derivative. You guys ready? So here we go, guys. I'm going to go f prime of x equals what's the derivative of x cubed? 3x squared minus what's the derivative of 9x? 9. I set that sucker equal to 0. Oh, sorry. Are we okay so far? Now we're done, guys. You're done with calculus. You're just doing algebra. 3x squared equals 9. Divide both sides by 3. X squared equals 3. And then what do I do to get rid of that square there? So x equals plus minus square root of 3. Now be careful. They're going to try and trick you. So catch up to here. At first glance, some of you are going to look at this and you're going to see letter B and you're going to circle letter B. I want someone to tell me why letter B cannot be it. Tell me, Wilson.
Because the interval is 0 to 3.
Excellent. They tricked you. The interval, you're only looking between 0 and 3, guys. You're only looking between 0 and 3. You cannot be negative square root of 3. That's awesome, Wilson. So are we cool with that? So here we go, guys. So the only answer has to be square root of 3. So let me write this down here on the side. Negative square root of 3 is not on the interval. How do we feel? Okay. Here we go. We're going to go slow. We don't care right now. I just want to know if the conditions are met. What are the conditions again? Let me say it again. The conditions are continuous on closed interval and differentiable on open interval. And don't be a robot. Are we ready? Letter A, let's see your algebra. So we have square root of absolute value of x, plus 1 from negative 1 to 1. Do you know how the absolute value of x plus 1 looks like? From your algebra days, absolute value of x is just a v, and then the plus 1 just moves that graph what? 1 up. So it looks like this. I'm looking on the interval between negative 1 and 1. Negative 1. 1. Can I use the mean value theorem?
No.
No, why not? No, you're right.
I forgot how to explain it.
No, tell me.
Okay, so since there's a point.
There's a point?
Which means that there will never be a tangent line that will, yeah.
So what do I call this? No, tell me. What do I call that?
A point of inflection?
No.
No. Okay. I shouldn't have raised my hand.
No. Hey, you're good. It's a safe space. It starts with letter C. Second letter O.
Why am I drawing a blank?
Third letter R. It's a corner. And all right, guys, you're okay. And you are not differential in a corner. So because you're not differential in a corner, mean value theorem does not apply. Are we okay with that? Okay. Yes, ask, please.
How can someone do this in real life? What is it?
Yeah, okay. No, that's a good question. So how can someone use this in real life? Let's go back to this question over here. Let's go back to this. So let's say, let's use the example of you're in a car. If you're in a car, because we just used this a little while ago, and hopefully this made sense to you. If you're in a vehicle and you drive from here to South Padre Island because you want to have a good time, and then you get to South Padre Island and the odometer says that your average speed was 57 miles per hour. Was your instantaneous speed at any moment 57 miles per hour? Yeah, it had to. Maybe you went on cruise control all the way 57. Maybe you went all the way to 60 and then back to 40 and then back to 75. And then you hit, I forgot the speed that I said, 60 something several times, the average speed limit. That's all it means, that your average equals your instantaneous. So all it means, the mean value theorem, is that your instantaneous equals your average at some time in that interval.
Oh, so it's just like a statement.
It's just a statement, but I want you to look at this one though. So let's say this was speed, and it's not possible to change speeds in a moment like this. But let's say I was going, it's a negative slope, but I'm just gonna make up a number. This was 30 miles an hour, and then I went from 30 miles an hour to 10 miles an hour in a moment, which is not possible. But let's just say, so I went from 30 miles an hour to 10 miles an hour in a moment, meaning that in a moment I didn't even go through 20 through 10. I just went from 30 to 10 right off the bat. Then I cannot use mean value theorem because you're not differential at that moment. It's not possible to go from 30 to 10 right off the bat. It's not possible. Does that make sense? Yes. Okay. So what is mean value theorem? All it means is that your instantaneous rate of change equals your average rate of change at some moment. That's all it means. Yeah. And it's not, I wouldn't say it's anything fancy or powerful, but it just means at some moment that you equal this number. That's it. Similar to intermediate value theorem. Did that kind of make sense to you or not? Are you sure? All right, give me an example. Give me the same example, or a new one if you can think of one. Yeah.
Like driving?
Or like anything.
Okay, like
Anything. Can you think of other rates of change?
how About
Yeah, swimming.
Like someone's, it's a professional swimmer who's trying to like get their pace up, whatever. Then,
Oh, I like that. Someone's trying to get their pace up.
Yeah, like for the competition, so they're swimming. He's like going at like 5 right now. I don't know, 5 whatever.
5 knots or 5 miles per hour. Okay.
And then he's like, then he starts slowing down a bit to 2. And so this guy's like, keep it up. So like, you'll go faster, and he goes faster. And then like goes up to 10 or something. So then they're like looking for this race, for this practice, you give it like an average of this.
So at some moment you were hitting that. Okay, I we need a tweak, but you have the right idea. No, okay. Espinosa said this: you're swimming. Your average rate of change was 7 feet per second, or whatever swimming is. Yeah, 7 miles per hour. So that means when you were swimming, you must have hit 7 miles per hour at least somewhere down the line, because they're continuous and differentiable. But yeah, I like that, miss. We need more experience. We're just getting started, guys. It is the first day, so relax. Okay, and then I put this in here. This we already have lots of experience, but not formally. Oh, did we skip a problem? Oh, dang. Okay, here we go. Let's not skip any problems. Square root of x looks like this. Here's 0. Here's 1. Can I use the mean value theorem on this question? Yes, you're continuous on 0 to 1, and you're differential from 0 to 1. Cool or not cool? You know what? While we're at it, let's figure this out. I have an okay, let me zoom. Let me exaggerate my curve and let me zoom in. So let me exaggerate it, guys. And I'm going to call that guy right there number 1. So I'm going to say that's 1. So here's my average rate of change. The line is not the average rate of change. The slope of that purple line is the average rate of change. Are we okay? Okay. F of 1 minus f of 0 divided by 1 minus 0. Don't worry, this is not anything heavy to compute. There's the square root of x. What's the square root of 1? 1. So 1 minus 0 divided by 1 is just 1. So the slope of that purple line is 1. Yay or nay? I have a tangent line that is parallel to that purple line. Somewhere right there. Looks like that red line is parallel to that purple line. Cool or not cool? We're going to find that x value. I'm going to put it C. So what do I do to find that C value? I want my instantaneous rate of change. How do I find the slope of a tangent line? Take a what? Derivative. So I'm going to write g prime of x equals, what's the derivative of x to the half?
1/2.
Perfect. So 1 over 2 square root of x. Are we okay so far? I'm going to equal this to my average rate of change. What was my average rate of change? 1. So 1 over 2 square root of x equals 1. You can also put c if you want to find, you know what, let's put c because we're finding that specific value. We're finding this value right there. So I want to solve for c, guys. We're done with calculus. It's just algebra. Times, so we have 1 equals 2 square root of c. Are we still okay? Divide both sides by 2, so square root of c equals 1/2. And then how do I get rid of that square root? Square. So c equals 1/4. At x equals 1/4, that's where that happens. So c at x equals 1/4, I have a tangent line that is parallel to that secant line. Cool or not cool? Okay. I think we're doing good, guys. Okay. For now, don't worry, we're going to practice more on this, on MVT, but I wanted to do 2 lessons in one day, and I think you will thank me that we made it short. I could have done all day MVT, but I wanted to also do this, and since I don't have much time, so we're doing 2 lessons in one day, but they're short. You guys ready? All we're doing, you guys already did this. If f prime of x equals g prime of x at each point on the interval I, and there is the constant c such that f of x equals g of x plus c for all x on I. Oh, what is that? Function with the same derivative differ by a constant. Okay. I guess that wasn't even worthy. Function with the same derivative differ by a constant. Okay, look at this, guys. F of x equals... okay, I'm going to put derivative. F prime equals sine x. No. I'm going to put f of x. Sine x plus 1, f of x equals sine x plus 10. And you know what? Let me change it to g of x. f, g, and h. H of x equals sine x plus 100. What's the derivative of sine x plus 1? Cosine x. What's the derivative of sine x plus 10? Cosine x. What's the derivative of sine x plus 100? Cosine x. Notice that all of them are cosine x. Do we notice that, guys? Okay. All of these, sine x plus 1, sine x plus 10, sine x plus 100, just differ by a constant. Do you notice that? The constant is a 1, the constant is a 10, the constant is 100. So from now on, when we say what's the antiderivative of cosine x, you're going to say f of x equals sine x plus c, which is true. See? It's just a constant. Antiderivative of g of x, of course, they got to give you a condition for you to figure out what that 10 is. And you've already done this. Sine x plus c, antiderivative of h of x equals sine x plus c. And then how do I find that 100? How do I find that 10? How do I find that 1? They got to give you either an initial condition or a condition to solve for that c. And you've done that with position, velocity, acceleration. Do you guys remember? Okay, so now we're finally starting to get more and more experience. All right, let's see. What does it say? Find the function f of x whose derivative is sine x, and the graph passes through the point 0, 2. Okay, so here's what it says. They want me to find the function f of x whose derivative is sine x. So write f prime of x equals sine x. And I pass through the point 0, 2. So that's what I'm talking about. It doesn't have to be an initial condition. It can just be any condition. So they told me when x is 0, my y value is 2. So I'm going to write, that means f of 0 equals 2. That's what that means. Are we okay? All right. What's the antiderivative of sine x? We just did it. Cosine x. Let's see. Oh, wait. Positive or negative?
Positive.
Yeah. No, but the derivative of cosine is negative sine, no? So it should be negative. Yeah, because we didn't do that one. We did antiderivative of cosine x. So now we're doing antiderivative of sine x. Does everyone see where I got the negative cosine x? How do you test yourself? What's the derivative of cosine x? Negative sine, but there's not a negative there, so you got to put a negative in the cosine x. The derivative of negative cosine x is a positive sign. Yay or nay? Okay, now use this. Oh, that was a very sad hey, yay, yay. Now use this to figure out what the c value is. 2 equals negative cosine of 0 plus c. It's baby pre-calc. What is cosine of 0? 1, but I have a negative there, so 2 equals negative 1 plus c. Move the 1 to the other side. C has to equal 3. Now that I know that c equals 3, you come back and you say f of x equals negative cosine x plus 3. Are we okay? Yeah. All right, there it is. That's it. And don't worry about all these fancy f capital and all that stuff. If function of f is an antiderivative of a function f of x, if f prime blah, blah, blah equals in the domain of f, the process of finding anti-differentiation. Okay, whatever. All right. Yeah, don't worry about all these capital letters and all that good stuff. We'll break it down when we start doing the fundamental theorem of calculus and all that good stuff. All right. All right. Come on, again, focus, miss. So here we go. All I'm doing is finding my antiderivative, finding the f. So I'm going to write f of x equals what's antiderivative of x?
X squared.
X squared over 2 plus c. If I take the derivative of x squared over 2, I get x. That's how you can figure out.
Yeah.
If you take the derivative of x squared over 2,
I feel like I would not get it.
okay.
I'd just be looking at it.
All right. Time out. When you take a derivative, think about what you did. I'm taking derivative right now, not right now with these, but when you take a derivative, what do you do if it's a polynomial or if it's a variable with a power in the top? You multiply by the coefficient and you subtract 1. So now reverse it and opposite. Opposite and reverse it. Did I say that right? Okay, here's what I mean. You know how we said multiply and then subtract 1? Well, now we're going to add and divide. Like reverse the operation, but and opposite. See? So this is a power 1. Add 1 to that. What's 1 plus 1? And divide by that number. See? We know this, guys. You've done it before. This is the same thing as 1/2 x squared plus c. And look, check it out. 2 times 1/2 is 1. And then subtract from the 2, that's a 1. So that gives me that x to the power 1. Do you guys see that? All right, now let's see. Letter B. I'm on the one on the right-hand side. What is my f of x? 2x. Don't just say 2x plus what? Plus c. Yay or nay? All right, here we go. We got a polynomial. Letter C. Don't worry. Let's see if we can figure it out. F of x equals, what did I say to do? Add 1, divide. So 3x cubed divided by 3 is just x cubed minus x squared plus x plus c. And to test yourself if you got it right, take a derivative. The derivative of x cubed is 3x squared. The derivative of x squared is 2x. The derivative of x is 1. And the derivative of constant is 0. Yep, I get that expression. Do you see how we're doing it? What's the derivative of sine x? Oh, I'm sorry, antiderivative of sine x. Negative cosine x plus c. Didn't get tricked. The derivative of cosine is negative sine, but does that have a negative? No, so you got to put a negative with the cosine. Cool or not cool? Cool. Let's go to letter E. That's antiderivative of e to the x. These are the easy ones. E to the x plus c. Uh-oh, Chav, I don't know if I'll be able to do this one. Relax. It's not a hard one. If you want, you can do this. You don't, actually, no, don't. That's the worst idea. Yeah, because I didn't see it until just right now. This is similar to f prime of x equals 1 over x. What is the antiderivative of 1 over x? Perfect. ln, and actually put an absolute value on x because of the domain stuff, plus c. But now that would have been for 1 over x, right? But I have x minus 1, so I write x minus 1 inside like that, plus c. As long as you have a linear term in the denominator, this will always be true. It has to be a linear term. 3x plus 5, 2x plus 5, x minus 3, anything like that. Cool or not cool? Cool. Oh yeah, we got tissues. All right. Finally, we get to this. No, relax. It says we don't want to leave the semester without seeing the integral symbol. We'll chat about the fundamental theorem of calculus in detail when we come back. For now, let's just practice. So look, relax. This is called an integral symbol or integrand. The integral is where you start, the dx is where you stop, and it looks like this. Let me write the definition at the top. Integral of f prime of x dx is equal to f of x plus c. So it just means antiderivative. And don't worry, I know you guys are like, okay, Chop, but why does it mean antiderivative? That's where we're going to talk about the fundamental theorem of calculus. We will talk about it because it's super important. But right now, I just want to expose you. We're a little behind. I know. I don't know how we got behind. It's probably more my fault than anyone's fault. But I want to make sure that we know what this symbol means before we leave for the semester. Okay, so that's all we're doing. Okay, so here we go. This, now that we know, look up here. Now that we know that just means antiderivative, we're going to rewrite this to make it easier for us. Integral, parenthesis, 2x to the negative 2, close it, dx. Sometimes you don't see parentheses. Sometimes you just see integral 2x to the negative 2 dx because it's known like that the 2x to the negative 2 is your f of x, f prime of x. Well, we'll talk about that when we start doing FTOC. Okay, here we go. What's the antiderivative of that? Add 1 to that exponent and divide by that. So 2x to the negative 1 divided by negative 1. So negative 2 over x plus c. Is everyone okay with that? Okay, here we go. I'm going to the next one. I'm going to break it down and I'm going to go slow. I'm dividing by x squared. Break it down like this. Integral 3x cubed over x squared minus 4 over x squared dx. I'm going to break it down some more. These are not ln's. or that one's definitely not an ln. It's not a linear expression. 2 of these x's cancel out, so I have 3x minus 4x to the negative 2 dx. Okay, now we're ready. Have I confused anyone? Okay, what's antiderivative of 3x? You can say it. Be brave. Antiderivative of 3x.
X squared.
Perfect. 3 over 2x squared. You can say 3x squared over 2. It's all the same. Cool or not cool? Cool. What's antiderivative of 4x to the negative 2? Add 1 to that negative 2 and divide by a negative. Negative divided by negative turns into a positive, so it's going to be 4 over x. Do you guys see that? Plus what? C. Put that in there. This is Travis. Yes, I will. Thank you. It's attendance. I'll post it in a little bit. Are we okay with that? Okay, let's go to the next one, guys. Relax. You know this. Make it where it's easier for you. Look, integral 3x squared plus 7x to the half. I haven't done anything yet, so that's why I got to put it with that integral symbol. Plus x to the negative 3 dx. Now we're going to do antiderivative. Ready? What's antiderivative of 3x squared? X cubed. Add 1, divide by that number. Cool or not cool? Plus, what's antiderivative of 7x to the half? You can look to make it easy. I know this is the first time we've gotten this. Look, make it easy. I'm writing a 7, x to the 3 halves, and I'm going to divide by 3 halves, which is the same as multiplying by 2/3. Do you guys see what I did?
Yeah.
Okay, so don't worry, I'm going to fix it in a little bit. And then minus, because I'm going to divide by a negative. Negative 3 plus 1 is negative 2, and I'm going to divide by negative 2. So x to the negative 2 divided by 2 plus c. So here I am. I'm going to fix it. You guys ready? Fixing it, it's going to look like this. X cubed is just stays like that. 7 times 2 is 14. So 14 over 3 x to the 3 halves minus 1/2 1 over 2x squared, plus c. The x squared is in the bottom. And there it is. How do we feel? Okay. All right. This one right here. Antiderivative of 1 over x. It starts with the letter L. Ln absolute value of x. Plus, this one is not an ln because it's squared. Ln only for linear, if you have a linear in the denominator. Linear expression. I have an x squared, so you can bring this up. X to the negative 2. So it's going to be a minus then. Minus 1 over x, because you add 1, divide by that number. Are we still okay? Mm-hmm. This 2 over x cubed is 2x to the negative 3. So let's see. Add 1, negative 2, divide by that number, negative 2. So minus 1 over x squared. Do you see how I got it? I don't think I made a mistake. Yeah, because there's a 2 there. So the 2 goes away when you divide by negative 2. Mm-hmm. And then what else am I missing? Plus c. How do we feel? Okay, now all we need is practice, guys. So these are your last UH quizzes. UH quiz 11 and UH quiz 25. And then we have 2 more circuits, Tuesday and Thursday, and then review Wednesday, and semester exam next week. We're okay?
Are we teaching the semester exam on Monday or?
Monday, because you guys are second period. So it's best to just get it out of the way, so it's a good thing. All right, guys. Take care. Oh, well, what?
How long is it? Like, what's the structure? Is it going to be AP stuff?
Oh, it's going to be like AP, like an AP exam. I'm going to give you guys a packet for review.
Freestyle questions?
Say, what?
Like, pre-response as well?
Yeah, the whole shebang.
How are you going to grade it?